All right, so you can see the tangent equation, and so we're going to graph one. And tangents and cotangents are basically, they kind of have an S-shaped look to them. So first thing is I look right here, and there's a 3, which is not really called amplitude anymore, and for sine or like we had for sine or cosine, but for tangent, it's really kind of a steepness, meaning do you have an S that's just kind of like this, or is it really skinny, or is it really wide? And so I'm just going to call the steepness 3. The midline is over here at 1. The B value, again, sits right here. There's nothing there, so we assume that it's a 1. Or not assume, but it is a 1. Now, we have to be careful here because the rule for period and the critical points changes for the tangent curves and cotangent curves. The period now is pi divided by b, so that'd be pi over 1 or just pi, and the critical points would be the period divided by 2, and so that's pi over 2. So a little bit of a rule change from doing sines and cosines, so be extremely careful. Now if you look at the phase shift, this would be x minus pi over 2 gets set equal to 0, and remember, if you move a pi over 2 to the other side, it's simply pi over 2. So my first critical value I'm going to write down is pi over 2. And then just like sine or cosines, we're going to go ahead and add the critical point, the spacing. So we're going to add another pi over 2, which would put me at 1 pi. And then I add another one, which would put me at 3 pi over 2. And I add another one, which would put me at 2 pi. And adding the last one would put me at 5 pi over 2, or 2.5, 2.5. Now some people might look at this and say, wait a minute, the last minus the first. So 5 pi over 2 minus pi over 2 gives us 4 pi over 2, which is 2 pi, and yet the period of the function is only pi. Well, when I ask you to do 5 dots for tangent, it actually is going to be 2 periods of the function. So I just do this so that we're consistent on all graphs. Do 5 dots. Other instructions and places might say do 1 period of the function, and in this case you could just do 3 dots, but we're going to do 5 so that we're consistent. Now remember, the midline kind of is up 1, so we'll put it up 1, and this is just to help us locate where the zeros are. And then the steepness, I'm going to show you how we do that. We're going to go up 3 more, which would put us at 4, and down 3 more, which would put us at -2. So when I go to graph this, remember the tangent wants to go up to the right, and it goes 0, asymptote, 0, asymptote, and it just keeps repeating. So the very first critical value will be a 0. The next one will be a vertical asymptote. The next one is a 0, vertical asymptote, and a 0. And then I would just normally just say, oh, let's go up to the right with a couple of our graphs. So up to the right, down to the left. That's what the S-shaped curves would look like. But they have changed the steepness to 3. So just to represent this, I go halfway between the dot and the asymptote, and I go up to that steepness part. And so this would be a little bit steeper. And again, halfway between, I go up 3. And in between the asymptote and the 0, I would go down 3, which would be down there. And so it just would look something like that. And that's one way you can get that in there. But the big thing that we would be looking at is, does your tangent graph go up to the right in this case? Do you have the correct critical values along the x-axis?